Welcome back to Berlin, and it's good to be back here on stage. Today we are going to discuss pretty introductory, but of course a little more detailed about how, as a mobile developer, specifically as an Android engineer, you can enhance your app security. So this is Mani. I'm working for SumUp. It's a bank, and also it accepts payments. We have a booth here, so if you are interested, you could check out more about what we do. So the story goes back to last year, where, as I said, like, we actually work for a bank. I work for a bank. We always need to make sure like we have pretty strong security practices being implemented. So what happened is our app binary has been put under VAPT tests, so-called VAPT. It's just vulnerability and penetration tests. That's what you call it, shortened with VAPT. So what they do is they try to kind of break your app, and they do all kind of things on your app binary to see if there is something wrong in your application. So interestingly, we of course found some interesting things over that, and we need to fix it up. We did eventually fix it, as we always need to. However, that actually created a question in my mind about how come these items didn't even strike my technology experience from past 10 years in Android development. And so in the next 40 minutes, we are actually going to talk pretty much about the basic things we keep hearing, however, we really don't pay attention to, and how is it the hackers, or pretty much most of the people, try to break even into your application, which we always think that is secure. So what comes to your mind when it comes to app security? The first 5 things that comes to your mind are obfuscation. That's the first thing I always say. Hey, my app is ProGuard enabled, so that means my code is obfuscated. And yeah, it's a release mode. You always have it. Recently, we also have encrypted shared preferences that would make sure whatever you store in your local is cannot be readable. Basically a ciphertext, not a plain text. And your HTTP calls, and making sure like your dependencies are good enough. So, but then, as I mentioned, after my VAPT tests, I realized that whatever I kind of thought are to some extent true, but not really completely true. The first thing, as I kind of keep saying, it's about obfuscated code. So obfuscated code, I thought like, okay, it's kind of bulletproof, at least people cannot see my code. But then there are professional grade tools like JBD compiler, even Google has Njarify, and these libraries that could pretty much whatever you kind of obfuscated could be reverse engineered and then deobfuscated back to kind of look at your code. And even when it comes to encryption, shared preferences, as we all know, that it could be pretty much easily read. And we also know that from starting Android 9, most of the data is being encrypted on disk. However, in the next slides, we are going to see how your data, it's okay that it has been encrypted, but hackers doesn't really care about whether it is encrypted or not, because you could still get a lot of things done with the ciphertext itself. So we are going to delve deep into it. And just for you all to know, encrypted shared preferences internally uses Google's Tink library, which is the base of the security. And the second thing is also about, it uses a Jetpack crypto library. That's the base of encrypted shared preferences. At the end of the day, it kind of gets the keys, and it performs pretty much all of these items. Silently, Google has last year deprecated those. It's Google things, right? So that basically means, as we get to see here, it's open source. They already kind of merged it. More or less this year, I think you will soon, maybe we would soon hear that the encrypted shared preferences is going to be deprecated. Hopefully not, but we never know. The third one is about API calls. I'm pretty sure we are using retrofit, HTTPS, gRPC, or whatever the network calls that you're using. This is one of the major things that we always see about. There's something called as man-in-the-middle attacks. So what happens whenever you perform API calls from your device is you hit your server. Before doing anything, you need to always do SSL handshake. That means your device needs to know that, okay, you are actually talking to a secure server. So it first asks like, hey, tell me your certificate. It's just like asking if I go to any country, they initially ask you, okay, show me your certificate or your valid proof. So what I do, I just show my proof and they kind of check it. Is it all good? If it is good, then they say like, okay, you are a legally verified person. That's exactly what even a mobile app does. It quickly asks the server, whomever it is communicating to, for a certificate. They kind of share your public key. And what does Android do? It kind of checks it against their key store, trusted store, which is Google Store. So what it does is it will check whether the certificate is verified. In this case, imagine someone is in the middle. They could also create a self-signed certificate, and they could also say like, naturally it will be verified, right? So it says like it is verified, and then the person in the middle can, they could just keep deciphering. So what they do is they will sit in between the mobile device and the server. The mobile device thinks like it is always talking to the public key of the server. However, they're actually talking to the public key of the middleman, and whatever is talking, they kind of decipher it and then they forward the request, which means most of your network security could be read by the middleman, which is technically what we call it as kind of man-in-the-middle attacks. And there are a lot of applications, unfortunately banking as well, and not following how to make sure like you would avoid man-in-the-middle attacks. We are going to talk a little bit brief about it. So what's the solution? One way is just assuming like, okay, everything is good, which is what I've been doing from past 9 years, I would say. But however, you need to fix it. Unfortunately, security is a thing that becomes a priority until someone actually does something on your app. So the strategy that we kind of followed is shift left. In any of the paradigms, programming paradigms, it's either shift right, which is after releasing something, you do something, you act on it. Shift left is before releasing something, you have some set of items you mark as a checklist to make sure like you're not creating any problems. So what are the top security vulnerabilities in the app, or how could you even address them? The top 6, or I would say 7 things as part of OWASP. It's an open source driven community. What they say is like the top 7 things are securing your app binaries, called as app tampering, the data that you're storing in your system, cryptography, the keys, whatever you have, networking calls, which we just talked about, and also making sure like strong platform interaction. So what I meant by strong platform interactions, at the end of the day, your app is a process that is running in its own sandbox. That's how Android does it. It's a Linux process and it's just spawning threads. The only way someone can get into the process is nothing but, there are 4 important entry gates. They are nothing but your Android components: activities, views, fragments, whatever you call, your broadcast receivers, your content providers. So these are the 4 major things that you get into it. So what is the strongest way to secure any place is first secure your borders. Exactly what they do in the mobile apps also. You need to make sure you secure your entry gates into the system. So I think we had a lot of talk. So what we're going to look at is sample examples of how you could do all of these things. Or what I did is I just created a sample application, which is a vulnerable application, which shows that how could you write a code which could be easily read by or which could be easily been deciphered by the hacker and do some stuff. This is a vulnerable application. What it just does is you could log into the system, you log in, and then it just lists down a list of things, and it has a web view. So you load some web view stuff on there. From this code, I have an example of all the 5 items that we kind of talked about, and let's see what you could do with all of this. The point number 1, as we all know, shared preferences. I just try to store the data. Whenever someone clicks on login, it stores the username and password. This is something we won't do for sure. But let's suppose you're storing some user information after user has been logged in, maybe their user ID or some code and things like that. As you get to see, the code is pretty much, it's a bytecode. Just to give much more relevance to the system, I made sure like I had the bytecode here. It's just storing the simple information into the preferences. And as you can see, I could just get into the device, get into the package, file information, and the username and password is pretty much plain and visible to user, which is exactly why we always use encrypted shared preferences. Encrypted shared preferences, the library, it offers you really nice APIs, wrapper APIs. So all you do is whenever you store the data, now you will still have the preferences file. However, in this case, as you get to see, is a little bit encrypted, so you cannot understand what is being stored, which is what we think like is actually security, which indeed is, but let's see, is it really the case? Generally, what does a hacker do, or a vulnerable person do, is first things first, anytime you want to break any code, you need to understand the keys. Like if you want to break even into a house, what do? You first break the doors, right? And how do you break it? Get the keys, or you just break the doors. So any strong system is not really strong as long as your keys are not strong. So what they do is first they try to find the keys. What keys are they using? So Frida is actually, any hacker knows Frida. What Frida is basically an open source APIs, which you can just use to run the scripts. They have ready-to-made scripts that you could run on your app binary. Just give them the package name, tell where the file location is, and it runs their scripts onto your binary, and it actually quickly gives you, as you get to see, I just ran it on my app. It already says what kind of key am I using, the algorithm am I using. The moment I know what algorithm am I using, I could just uninstall the app and just rerun it again onto the app. And this time what they do is they observe when this specific type of key, decryption and encryption, is happening. And then what happens is you could quickly see in the logs there that the username and password when I'm entering could be easily seen before even getting entry into the system. But there is another aspect of it. We could say like, okay, before entering into the system, people are able to see it, but what happens even after the data is inserted? That is something we are going to talk about. So the first important thing for any system or any application is to make sure your keys are managed well. So it doesn't matter how strong your storage is, all it matters is how strong is your keys are. So what should we do? So the common vulnerabilities are generally, how do they even break your key store? Like key store is the one which Android provides to us. It's called as Android key store. I think we all know about it. So that is where you could ideally generate a key. Point number one, I think by this explanation, you already know that you should not hard code keys at all, because it's a straightforward way to kind of get things off. That means you need to have a way to generate keys. So how do you generate keys? You generate keys by asking the Android, the local API, to create a deterministic key. Deterministic means every time I ask for a key, it should give the same key. It should not give random keys. Then my encrypted logic is gone. So there are two ways. What Android Key Store provides is two ways of doing it. One is BKS. The other one is Strongbox backed. BKS is basically software enabled. I'm an Android engineer, but I'm still, if anytime I hear software, I'm pretty sure like it could be somehow breaked into system. And actually it is. So what did Google do, or Android does, is they hardcode this key storage into a chip, physical chip. So every Android device comes with a Strongbox. They call it Strongbox. That is actually embedded into the chip itself. So you could not just break even. Whatever the code that is there, it will go into the chip. So they call it Strongbox. That's something, what you need to make sure is whenever you are trying to generate a key, you always try to store the keys in the Strongbox. You have ready to use APIs. And the third one is whenever you're having these keys, specifically something which is super sensitive, what people do is they don't set any kind of authentication. I have not done it, so let me be open. So these are the common vulnerabilities. What people do is the moment the hacker or anyone try to get hold of your device, All they do is, it doesn't matter how the data has been stored, as long as you have not added the common vulnerabilities that we are seeing, people can just get into the system and they could get access to it. It's so simple. Like, user will allow access, for example, you have the very strong key storage. Maybe you kept user authentication to get into it. But the point is, the moment you get into the system, you also need to set up some valid time. Like, the moment you authenticate, it's like having a session validity time for 2 years. That means if you're authenticated on day 1, for the next 2 years, you can keep getting data. It's the same here also. So we need to make sure, like, you invalidate the access. So how do you do it? So this is a quick example of another Frida script that actually traces all of the keys. It also tells you all the vulnerabilities. As you get to see here in this script, it's already telling that, is the code stored in a secure hardware? Yes, in this case. Did I enable biometric authentication for keys? No. Did I set any validity for the keys? No. As you get to see, like, these are all vulnerabilities. So hacker doesn't really require more than 30 minutes to quickly break even into your app storage. So we thought, like, as I mentioned before, ciphertext. In one way, as I said, people really don't need to know the plain text. Even using your ciphertext, people can do anything they want. As you all know, like in cryptography, the concept of cryptography is you have plain text, human readable text. You give a key, you feed these two things to an algorithm. You will tell what kind of algorithm it is. And the algorithm will output a ciphertext, which is, no one can read it. And then, whenever you give the ciphertext and the key that you encrypted with, it will give back the plain text. That's a pretty thing. And the only thing it needs to be is deterministic. Deterministic means you always get the same output when you give the same input. So when you have a ciphertext and when you know the key, as you get to see before, I've shown the key, all they could do is they just copy it. They copy whatever the encrypted text they have. They know the key that they are using. And all of the algorithms are open source. If it is not, they could even take from the code that you have written, and they could run the same local program to just see what your data is. So it really doesn't matter in a sense that, yeah, it is a ciphertext, but it's not really secure. So what you need to do is, my quick checklist, as I've kind of mentioned, is whenever you're creating an object, whenever you're storing into the Android key store is the way, make sure, like, you set the strong box enabled to true. And then you set the biometrics enabled to true. That means if anyone is trying to access the storage, they should get authenticated either with a fingerprint or the PIN that the user device sets up. If it is not set, user can't access. Pretty simple. And also make sure, like, you set the time, like for how long the session needs to be valid. That will make sure that you are not giving an infinite amount of valid time. So the moment you do at least this checklist, you are, I would say, 80 to 90% good enough in ensuring, like, the data is secure, until and unless the hacker breaks the device and get the physical chip. In that case, anyways, no one can read the data. It's of no use. So that's what we actually started doing. And this is a quick example of how you could do it. GitHub repository, they did the same thing before too. And many people will ask, as you get to see before, I gave a quick recipe that user needs to authenticate has to perform biometric authentication. But then you could ask me, hey, Mani, imagine I want to also put something like API keys. I want to keep my server's URL. You would have HTTP something, your endpoint URL, which is not really secure, but of course you don't want to expose it to the world. So what should I do in that case? So there is a saying, like, just make sure that it's not easy for the hacker to kind of read it. So I mean, in my view, what I always think is security is a state of mind. Just make sure, like, you try to make this process one step harder than what it used to be. So what I do is, since the previous API requires app authentication and biometric setup, and it's, of course, from the performance perspective, it takes a little bit more time, maybe 1 second, to kind of fetch this data. For things that really doesn't require to be super strong, but still requires a level of security, what you could do is you could put these things in your C++ code. So what that makes is whenever you do decompiling and things like that, you don't really need to worry about the data quickly being displayed whenever someone does deobfuscation of the code. So what you could do is you have an NDK library, you can store all of this data inside, and when, like, as you get to see a quick example of how you could keep the keys, and this would at least ensure like maybe intermediate hackers or intermediate level or not so hyper professional hackers could just pump into your system. So this is one more thing I kind of recommend. And coming to the network SSL pinning. SSL pinning is something you need to ensure that your app is secure, right? So what you need to do is, this is pretty easy. As I mentioned before, a quick example of how someone can make me valid is not by just looking at whether the document is valid or not. What they should do is whether the name on my document is matching my name. So they will check the face and my face. So they will make sure like, okay, the picture says the same, the name says the same, and the ID and the person is the same. It's the same thing you need to do with SSL pinning. When someone gives their public key to you, you need to make sure that public key matches that domain. So how could you do it? Your backend team knows you and your binary. So all you need to do is just make sure you ask your backend team to share the public key. They will do a base 64 encoding of that public key, and you just keep it in your network configuration. So Android has a straightforward configuration, network config.xml, and put the domain name, whatever your domain name is, and its corresponding base 64 encoded public key. That's pretty much it. That will make sure like Android always verifies it. And if you are using OKHTTP, that's what we actually do. Also, you have a ready-to-use API where you could just set the domain and the certificate pin. So that would make sure like you don't really need to worry about man-in-the-middle attacks. There is something people always say, like as a security protocol, every backend server has to rotate their certificates. So people ask me, oh, what if someone rotates their certificate? What would happen to my apps? Will I be locked out? Actually not. Backend engineers should ideally know, at least the DevOps engineers, because whenever you rotate the keys, you don't really need to rotate your public key file. But I think that's not our problem. They need to take care of it. We have enough to care about. So after SSL pinning, as I just mentioned, whenever you do the verification, no one can kind of bump into the system by being a man in the middle. And you always make sure like the certificate that is being provided is legitimate. That's a quick check. And then you have another item which we always keep looking at, as I mentioned, is securing your app gates. Web views are like really a thing. Whenever you use web views, you need to be really careful in trying to set web settings security, like web settings whenever you kind of create web view settings, JavaScript enabled to true. I mean, if something doesn't work, all I do is like settings.apply and then keep everything to true. I think that's something we need to be very careful of, because the moment you do things like that, users, at the end of the day, it's so easy for someone to operate or perform any kind of secure operations whenever someone gets into the app process. Because the moment you are in the app process, you are technically being termed as valid or authenticated user. That means you could access shared preferences. You could do anything that you want to do. And what you could do with web views specifically is whenever you export these kind of things, user can load any kind of URL, point number one. And then because you said like JavaScript enabled to true, they could execute some JavaScript that could actually access the local data. They could just take your app specific data that you might be using in your local side and then copy into a different folder, and then maybe they could expose it. That's called as a data lake. So how you could do it, as you get to see in the right side, you make sure like whenever you're trying to load URIs or URLs, you set specific components and just don't make sure like it's not selector enabled, because sometimes they would make sure like this kind of specific defective URL is opened by a specific component which they would install into the system, and that's it. And I mean, without your control, they could do pretty much everything. So this is a quick example of how you could do it. And this is an interesting case. Point number one, app information. If you're not following secure stuff, you are technically also exposing your backend. How? If you are working with AWS services, generally you'll have a YAML file that would have some AWS configurations stored into the system, which would mean potentially a hacker can understand the cognitive ID that you're using. Based on that, they could get the regions that they were in. Based on the regions, they can know the buckets, S3 buckets, which are publicly accessible. If our buckets are not secured properly, they could download all of the buckets information, which could technically have users information, and then that's how you call it a data leak. If you're just thinking, can this really happen? This is just a quick sneak peek of how many data leaks happen, and it's just page 1 out of page 40 in last 8 years on how much of a S3 bucket data leaks has happened. Most of them are government websites, and some of them are banks as well, but you can check those through. I have the GitHub link of it. It's pretty open source. So make sure that if you're not doing something properly in your app, you're potentially exposing your backend as well, which is, if it is not secured enough, could create havoc like this. And broadcast receivers. Whenever you're exposing your broadcast receivers, make sure that you are validating whomever is kind of calling. As you get to see in this case, my broadcast receiver is just trying to load a web URL. So what I did is, I just created another application, a Hacky app. All it does is, it just tries to, from my code base, the receiver is trying to look for a specific prefix, and if that app or the class or an activity starts with that specific prefix, it tries to invoke the code in it as long as it is extending an interface. So in this case, I just make sure, like, from the deobfuscated code, I could check that, okay, they are doing something like get package names dot starts with ABCD, and then as long as it extends an interface, they are going to execute the code. So I'll just create my sample app. I will expose the same thing, and I just wait for 2-3 minutes and then fire this event. That means your broadcast receiver will take this data and then it starts the app, which is exactly what happened now. So using the other app, I'm able to start this app as well. So what we need to do in general to make sure you secure things like this, as I mentioned, shift left. And the top 4 things that we just talked about is what we definitely need to do in your app as a daily practice. So secure coding principles is super important. But then comes to the question about how do I know that I'm doing something wrong? I mean, at least when we get to know that something is going wrong, that's when we can actually identify and fix it. So how you could know it? There are open source tools. So, I mean, I don't really, I'm not a big fan of trying to always use enterprise applications. Then they mask everything and you never know what's going around. So there is already an open source tool. MobSF, it's a community-driven security framework, which you could actually use to install in either in your local system or even put it in your CI/CD GitHub Actions. And then feed the app binary to it, and they would do the top 10, as I said, open source OWASP, the top 10 recommended approaches. They would try to run and analyze your app. What are the analysis that pretty much people do as part of penetration testing, in short, pen test, they do static analysis, SAST. Static analysis is one thing they do, which is done on the app binary. And then they do dynamic analysis. Dynamic analysis is what they do when they just use the app, and they will make sure, they will see like if something is going wrong. So when you see this secure data, secure shared preferences and things like that, that could be easily identified as part of SAST. And SSL pinning and issues, they could easily find it as part of DAST. So they would kind of run that across, and they will quickly give you a report, or at least that tool will give you a quick report to you, talking about, hey, you are doing something wrong, or these are the top 9 things that you probably need to fix it. It's just like how you run your unit tests on your pipeline, so you get a quick, immediate feedback or onto your app binaries. So this could be a quick check that you could probably do, take away, and then maybe implement in your daily stuff. If it is not a CI/CD, at least you could run once in a month to just see if things are on track and not burning. So what I did is, whatever I just mentioned, I did the same thing. I just ran it in my local. I just installed Docker in my system. As you get to see, in Docker, I kind of run the same command to install it. You could do it in your place as well. And what I kind of did is you could do in this case is you could, once it has been installed, you would know like if in this case I've installed and pretty much as usual live demos kind of breaks, but I'm looking for the URL which I want to listen to. Yeah. So as you get to see, it's a local instance, 0.0.0, and the moment you run it, you would actually know if something, and then you could just log into the system and you upload your binary. In this case, the vulnerable app that I've kind of installed, I created a APK, and then I uploaded it here, and it has already said whatever the issues that we could see. As you get to see, you get a quick view of the certificate and the keys that I've kind of used, the permission issues. As you get to see whatever I kind of explained, you could see it at a quick overview. It doesn't really require enterprise things where you need to pay for it. It gives you a quick overview of your applications. So I kind of started using it to kind of see if something is wrong, and they anyway make sure like all of this radar script, all of these things are up to date because it's community driven, people keep contributing. So we will at least make sure like we are on top of things. So this is a quick thing. I found it super interesting to kind of use. And as you get to see, you could also see the decompiled code and this really small thing which made it curious to me, Smalley source. Do you guys know what Smalley is? I see like some folks are raising their hands. It's interesting, and I also found about it last year. So maybe you guys would have already heard about it before, where in Android, you always get this premium application. So you could just have a, not a jailbreak, you don't really need to jailbreak or root your device, but you kind of get a premium YouTube and things like that. How do people do is generally hackers, they operate on this Smalley code. Smalley is nothing but, Smalley source is the code which is required for your Dalvik virtual machine. So that's an input for your DVM. So .dex files, at the end of the day, they'll have this Smalley code, which is nothing but machine level code. So all it has is some data about, as you get to see in my code, you have Sapiens. If you look at a simple example here, this is a Smalley code that has pretty much, it says like it takes a register, it's a machine level code, and it's trying to create an object and assigning it to a variable v0, and the object is some view holder. So what they do is they try to operate on top. You just need to know a little bit about how Smalley works, and then what they do is they just try to change this variable v0. Imagine if it is a Boolean is 1, and they kind of, instead of, there will be a function somewhere in the code, is premium user, which will return true or false, and instead of doing any API call or local preferences checks, all they would do is like they just return 1, and that would mean like your app is premium already. It's a quick interesting thing which I kind of found it that there are multiple ways for people to kind of get into your system. Maybe you can take away and then start trying to play around with it to see how things like this could be done. I found it pretty interesting to even play around. And one thing which I kind of realized is there are multiple ways app could be, there are multiple ways where an app could be hacked by unauthorized users, and we as an engineers has to be pretty much aware whenever we are trying to do some things. As I said, at least the top 9 things, as we just spoke about, they come under the top 9 things, the top 10 things of OWASP. And as long as, or at least as far as we cover these basics, we should be good. I know basics are not easy, but still. So my final checklist for security, make sure you're doing SSL pinning, pretty important. Make sure your keys are secure, or whenever you, as I said to you, secured keys are more important than your strongest cryptographic algorithms. Play integrity API is always there for us to make sure we have root detection and if your binary is kind of tampered. Secure your app kits. I already gave you examples on what not to do. It's like a preventive step. We already have an open source tool, which I kind of recommended. Maybe we could use it for SAST and DAST checks, so you frequently keep getting some feedback about how things are going. Database is already being encrypted, so for starting Android 9. If not, you already have SQL Cipher, which is an Android open source, which you could also use. So all of the SQLite data is encrypted by default without a performance hit from your application. And code obfuscation, you do it, but you already know, like, just because people can deobfuscate it doesn't mean like you open it by default. So make it a bit difficult for hackers to kind of get into. And this is something I also recommend for backend engineers, to make sure any access or configurations that you put in are granular. So you should make sure whenever any key is being provided to us, maybe it is better that key is granular enough that it's only accessible for Android binaries or specific users, so that even if someone gets into this kind of gets into this data, they would make sure like you are not exposing all of the users' information. There's a quick checklist, and I found like this is super helpful for me whenever I'm trying to do something. I'll just keep these kind of things in mind, which already made me kind of check that, okay, if I'm doing something, oh, this could happen, so I need to make sure like if there are any open source libraries to kind of fix it. And I found it super helpful, and I hope it is for you too. All the code is there in GitHub. You can kind of check it. The references which I've kind of looked at are also kind of added. Insecure app, kind of super helpful for me to kind of have some good references. Nuclei templates is where you could do these kind of enumerations on your app binaries. So, any questions?